Hello and welcome to this webinar. My name is Schimek and I'm a project leader at PORR Umwelttechnik. Today I'm going to talk about the identification of hazardous materials prior to demolition and will also introduce you to the legal situation in Austria. So let's start. I'm going to talk about the construction demolition waste in Austria. And then I will also focus on the regulation for recycled building materials and also the Austrian standard B3151. So construction of buildings doesn't only generate waste during the building process, but most of the waste is actually generated when buildings are demolished. So more than 1/3 of all European waste generated is construction and demolition waste. You can see the impact the proper recycling of construction demolition waste can actually have on a goal of achieving a circular economy. But how does the situation actually look like in Austria? The total waste in Austria amounted to more than 70 million tons in the year 2019. The construction and demolition sector generated around 12 million tons, which is nearly a quarter of all waste generated. Excavation material has even a higher share with nearly 60%. The chart also shows the development of the waste generation in Austria and illustrates again the high percentage of excavation material. And it is also observable that construction demolition waste is increasing with every year. So what are actually the reasons for recycling of construction demolition waste? On the one hand, the generation of reusable materials, as you use construction demolition waste, you recycle it and produce recycled product, which can be then let back into the construction sector. Second, you decrease therefore the resulting waste, which is especially important nowadays in order to save landfill volumes. And also in Austria, it is already very difficult to receive a permit for landfill sites, and it won't really get much easier in the future. Furthermore, you can also achieve a reduction of environmental impacts and also save primary resources. And you also minimize costs by using the resources more efficiently. And in case of a proper recycling with even selective dismantling, you can also generate sorted fractions of construction demolition waste. So for example, concrete, and mixed waste fractions will be decreased. And the better the waste fractions are sorted, the easier will be the recycling afterwards and also less costly. So in order to enhance circular economy, we should not only take into account the life cycle of the building, but also the life cycle of the building material. At the moment, there are actually two prevailing treatment ways after demolition. On the one hand, landfilling, and on the other hand, recycling construction demolition waste. But when having in mind the European waste hierarchy and also a sustainable approach, recycling should be definitely be favored. So in order to enhance a circular economy, it is inevitable to set up regulations which address the production, but also the use of construction demolition waste, so addressing really the whole cycle of these materials and not just one point in the cycle when producing recycled construction materials. So in Austria, we have the regulation for recycled building materials, which has been introduced in 2015. This regulation also refers to a different standard, which addresses specific sections like the Austrian standard B3151, but I will go more deep into the topic later on. So this regulation was introduced in January 2016 and has already been amended in October 2016. With that amendment, the possibility of reaching an end-of-waste status has been introduced according to the European Waste Framework Directive. And with that possibility, Austria is actually one of only very few European countries having an end-of-waste criteria for construction and demolition waste. This regulation also introduced high-quality standards for recycled building materials, which should also increase the trust in these materials and therefore increase the recycling again. So now I will go more into, I will go deeper into the topic of this regulation. So the section it actually covers. So first of all, the duties during construction demolition activities. The regulation lists requirements that have to be met during demolition activities. So for example, it specifies when and under what conditions an investigation for pollutants has to be conducted. And furthermore, the obligation for dismantling and separation of waste streams arise also from that regulation. So only non-hazardous waste is allowed to be used to produce recycled building materials, and hazardous substances and materials like asbestos, for example, as well as other impurities have to be removed prior to the treatment step of the waste. Then the regulation also covers the production and use of recycled building materials. This section actually specifies that recycled building materials are only allowed to be produced from certain waste types, which are listed in Annex 1 of the regulations. So for example, concrete waste. Hazardous substances are prohibited from the production of recycled building materials, as I have already mentioned. And in Annex 2 of the regulation, you can also find relevant quality requirements which have to be met by producers of recycled building materials. So thresholds for total contents and also for alloys to exist for different types of quality and also for different types of recycling building materials. The regulation also comprises areas of application for each quality and for each type of recycled building material. And it also mentions bans for the use. So for example, specific materials can be only used in bounded applications, whereas other qualities can be also used unbound. And for the first time, it was also possible to reach an end of waste criteria, but just in case a recycled building material reaches the best quality class UA, and the recycling material has to be handed over to a third party. Just then the waste status ends, and not prior or not before. So the regulation covers topics before and during demolition or dismantling. And for these single activities, the regulation refers to other standards. So in this case, to the Austrian standard B3151, which also includes further details on the single steps and also documents for each steps which have to be filled out. So the following steps are covered by the standard. It starts with an investigation of pollutants which has to be carried out. Then a concept for dismantling has to be prepared. Afterwards, the preparatory dismantling can start and the approval for dismantling is given. And finally, the mechanical dismantling can also start. We'll now go more into detail in each of these single steps to explain it a little bit better and to go more into detail into it. So first of all, the investigation of pollutants serves the assessment of the contamination of building pollutants of construction objects. So you not only consider pollutants, but you also take into account non-hazardous impurities. Prior to the demolition of a building, this investigation of pollutants has to be carried out in case a total of more than 750 tons of demolition waste will be produced in a demolition project. However, excavated soil has to be excluded. The investigation has to be carried out in accordance with the standard B3151. And it has to be carried out by an expert of demolition. And in order to become such an expert, you have to attend an educational course. And you also need a fundamental education in chemistry and construction technology. A list of these competent persons is published online and can be found on the internet. The second possibility of these investigations is in case a building volume of 3,500 cubic meters is exceeded. In that case, an investigation of pollutants has to be carried out in accordance with the standard 16032. And this investigation shall, in contrast to the first option, be carried out by an external authorized specialist or a specialist institute with knowledge of construction engineering. If you have less than 750 tons demolition waste, so for example, this is actually most of the cases for single-family houses, you do not have to conduct the pollutants exploration at all. You can do it, of course, but it isn't compulsory. So it is important to differentiate between a pollutant, which is hazardous for humans and also for the environment, and just mere impurities, which just make the treatment and recycling of other mineral waste difficult or even impede the recycling process. Both materials have to be removed prior to demolition, but the removal of these materials will be different depending on the hazardous properties, of course. So when removing pollutants, you have to guarantee a secure workspace and also avoid emitting any hazardous substances to the environment. So here are some examples of pollutants like slags, radioactive smoke detectors, PCBs containing materials, also PCB containing materials, and so on. And in case there is a suspicion that the material could be hazardous, a chemical analysis and further examination should be carried out in order to find out if this material is really hazardous or not, or if is it just an impurity. So let's take, for example, mineral wool. You can sample it and you can identify by analyzing it if this wool is hazardous or non-hazardous by checking its solubility or its fiber geometry. Another example are also insulation boards, which can contain HBCDD or CFC. There are actually thresholds which indicate if the material is hazardous or not, and you can then again identify the hazardous properties by sampling and analyzing them. So if you are insecure if a material is hazardous, the analysis will actually show whether or not this is the case. You then have to fill out a document, which you can see on the screen now. This one is taken from the standard B3151, and you have to cross either if a pollutant has been detected in the building or not. You can also give an estimation on the mass or amount of elements containing these hazardous substances. So here it says, for example, mineral oil containing elements or insulation material. So you can give further information on these materials. On this slide, you can see examples of impurities. So these materials and elements have to be removed too, but the removing process will be easier as they do not contain any hazardous substances or do not have hazardous properties. So examples of impurities are gypsum or non-hazardous mineral wool, floor constructions, or glass walls, and so on. Here you can also see the formula for impurities, which has to be filled out in the same way like the document for pollutants. So it's actually the same by making an estimation of the mass or telling how many types of materials you can find in the building. The next step is the preparation of a concept for dismantling. So what are actually the reasons for selective dismantling? Many scientific papers have already concluded that selective dismantling is really important for construction demolition waste in order to increase the recycling and to be able to achieve a proper recycling. It can maximize the amount of waste being recycled as you remove hazardous substances prior to demolition, which will enable a big amount of, for example, mineral construction demolition waste to be recycled. With pre-sorted waste, you also optimize the sorting of the waste at the recycling plant. You minimize the mixing up of different waste streams and also waste qualities, and you analyze prior to the demolition whether or not a substance is hazardous, and therefore you also prevent the emission of pollutants to the environment, so like CFCs, which can be found in insulation materials. The concept for dismantling has then to be prepared. It is actually a planning document which includes the steps you undergo to dismantle and demolish the building. You have to estimate the amount like for concrete, wood, metals, and every other main component of the building. A main component is main component is if it has reached more than 5% of the volume of all materials to be demolished in this building. And in case you transport the construction demolition waste to your recycling plant, you also have to hand over this concept of dismantling in order to prove that the mineral waste is free of these hazardous substances, and that you also show that the substances and the hazardous materials were removed before transporting the construction demolition waste to the plant. So now you finally start with the preparatory dismantling by clearing out the building, remove the pollutants, and also remove the impurities you have detected during the investigations of pollutants. On the picture, you see an example of PCB containing joints which had to be removed prior to demolition of a building in order to recycle the mineral waste afterwards. Then the approval of the clearance status of the building in accordance with the dismantling concept has to be given. This has to be done either by the expert of dismantling or the specialist institute, as I've already said before. And then you also see on the screen this document, which has to be signed by this expert of dismantling or the specialist institute. And afterwards, you have finally reached the point of starting the mechanical dismantling process, and the recycling of construction and demolition waste can finally start. So by removing hazardous materials and impurities prior to demolition, you can achieve a much higher quality of construction and demolition waste. These waste streams can be then easily recycled and finally be used as construction materials for new houses. And with this step, you close the loop and secondary products will substitute primary ones. So thank you very much for your attention. I hope you enjoyed it, and I hope you also have a nice day. Thank you.